Okay, Assalamualaikum and good afternoon everyone. So today we're going to learn about how to create graphical user interface. This is the last chapter of our course syllabus. Okay, so this chapter comprise what will you be doing for your mini project. Okay, so let's get started. Okay, so for most computer programs today make use of this graphical user interface, or commonly pronounced as GUI. So to create your own GUIs is easy in MATLAB, especially if you use the guide interface, but it does require that you understand some programming basics, which you have been introduced in our early weeks into this course. Okay, so before starting this section, it would be wise to review the concepts of structured arrays, subfunctions, and also handle graphics. Okay, so the M file created by the guide program uses a structured array to pass information between sections of the program, which each of these sections is a subfunctions, and components of the GUI are stored as properties of a graphics object using handle graphics. So generally, the first step in creating a GUI should be to carefully plan what the GUI should do and how it should look. A little planning will help you to avoid a lot of frustration. However, in this chapter, we will develop GUIs piecewise so that we can focus on how the program works. And be sure to try these comments out as you go through this chapter with me. So, for the first section, we're going to create a simple GUI with one user interaction. So what we are going to do is we're going to create a GUI that allows us to enter the number of sides on a polygon and then draws the polygon in polar coordinates. Okay, so to get started, we'll just select the guide icon from the toolbar. As shown here in this figure, or you can just type guide at a command line. Okay, so this is the quick start. This is the guide quick start. Okay, so when this guide quick start open up, simply just select the blank GUI template here, blank GUI default template located in the list here, to create a new project. Okay, so let's click OK. So once you select a blank GUI, this new figure window untitled.fig called the guide layout editor will open. Okay, so this is what we call guide layout editor. You can resize it to any shape that you want. Okay, by selecting the lower left hand corner of this grid to adjust the size. Okay, so if you want to resize this layout editor bigger than the figure window, so you have to resize the figure window first. Okay, and then you click and drag this lower right hand corner. Alright, so okay, so let's take a look at this GUI layout editor. Okay, so the default display for these icons is compact. Okay, so mine is not compact here. I have to some adjustment to this guide layout editor. Okay, you can adjust this button so that this button is informative for you, especially as a new user. Okay, so let's see how we can change the component palette display to a list. Okay, so to do that, okay, so click preference here from this home toolbar, home ribbon panel. Okay, then under guide, check the box for show names in component palette. Okay, so if you uncheck this box, okay, you can see that my guide layout toolbar is in compact display. Okay, so if I want it to be informative, so right now, especially for you as a new user, you don't really know what this icon is all about, so you want that icon to show names in the component palette. So you check this box and then apply, then hit OK. Okay, so now your button has been informative for you. So all this button on the left hand side of this guide layout editor is what we call as the component palette. Okay, so now your component palette has been slightly more user friendly than it is before. Okay, so we are going to move to our simple GUI. Okay, so remember that we're going to create a GUI which allows us to enter the number of sides on a polygon and then plots the polygon in polar coordinates. So we need 3 components in the GUI. The first one is the axis, a static text box, and an edit text box. You can pick them up and then arrange them in the guide layout editor here. Okay, so I'm gonna show you how. So first, let's pick an axis. Okay, so you draw an axis here. Okay, right below the axis, we're going to place a static text box. So you click once and then you drag the text box, place it below the axis, and then we need another edit text box. Place it right below the static box. Okay, so once we have them arranged like what I did here, we're going to use the property inspector to modify these design elements. Okay, so to do that, first let's modify the static text window. Make sure you click once on that static text box. Right click and then choose property inspector. Okay, so this property inspector toolbar will appear. Okay, so from this property toolbar, we're going to modify the static text box. Okay, so you can resize the property inspector window and then change the field, the string field here. Change the field from static text. So we are going to change from static text to enter the number of sites. Okay, next. Okay, next we're going to change the edit text box here. Okay, choose property window and go over to this edit text. So we're going to change from edit text to a blank. Okay. Okay, then let's save and run the guide window by clicking this green triangle button. Okay, shown as here is Graphical. Okay, click yes. Okay, you'll be prompted to enter a project name. So here, let's try this polygon underscore GUI, and then let's going to browse for a place. Okay, after that, what? So when the file runs, you should notice that the name of the GUI window changed here to a name that you save the file with, and an M file is created here. An M file is created with the appropriate code to create a window which user can interact. Okay, so now your next task is to add code to this M file to make the GUI do something. So right now you have the GUI, but the GUI cannot do anything because you haven't add appropriate code to the M file for the respective GUI. So you can see that the M file, if you browse this M file here, you scroll to the top, you can see that the M file is organized as a function with multiple sub-functions. Okay, so it uses a function and consists of multiple sub-functions. Okay, it has several functions here. So you can open a list of all the sub-functions in this M file. Okay, if you want to find out the list of functions consists of this M file, you can go to editor and then under navigate tool here, expand the go to. Okay, so you can find that there are 5 functions inside this M file. Okay, so you can simply navigate to any of these one function to add a code, okay, according to the sub-function name. Okay, so in this case, in this example, the only functions that we want to modify are labeled as the GUI opening function and also the edit one callback here. Okay, so alternatively, okay, you can also navigate to this guide editor, and then you can right click on the text box to locate the corresponding M file sub-function. Okay, for example, if you want to view the sub-functions for this static text box, you can right click and view callbacks, and then callback function. Okay, view callback. Okay, you can click, and then you will bring into this sub-function files inside the M file. Okay, so let's take a look at this GUI layout editor. So usually there will be a callback function. Okay, if you move your mouse here, there's a callback function for the graphics object that allow user to interact with the GUI. Okay, so the only interaction inside this simple GUI is from this edit to text box. So there's a callback function. Okay, so the other two doesn't have a callback function which allow user to interact with the graphics. Okay, so let's go to this callback function. Okay, so notice that most of the code is composed of comments. Okay, so you can see that it is composed of comments since it is made up of these green fonts inside the editor. Okay, so let's go to the callback function again. Okay, so notice that for this callback function, the first line here identifies the subfunction as edit1 callback with 3 inputs. Okay, so the other 1, 2 and 3 inputs. So the hash object here is a graphic handle that links the subfunction to the corresponding edit text box. The event data is a placeholder that the networks included, and this handles is a structured array which is used to pass information between the subfunctions. So all callbacks function will have a similar structure like this. Okay, so now let's modify this edit1 callback function. Okay, so you can see that there is no content here. There's just function and then makeup of this comment, so there will be no content. So you have to add the code so that your GUI will work out. Okay, so to add the code, we're going to modify this edit1 callback by adding this code inside this callback function. Okay, so let's look at this M file. So there's these hints, okay, which let you know that you have to use this get it function to retrieve information and use it in our M file. Okay, so we have this get hash object string, okay, which instructs MATLAB to retrieve the string property from the graphics object that was passed to the function as hash object, in this case the edit1 text box. So information, okay, the string property too is whatever string property is actually whatever information that comes from the user. This one here yang kita edit tadi dekat string tu. Okay, so since information stored in the string property is stored as a character array, so if you want to use the information as a numeric value, it is necessary to change the array type to double. Okay, so with this in mind, we're going to add this following code to this callback function. Okay, so here we're going to type size equals to, this is when you want to change the, you want to use the numeric value of the character array, so we have to change using the string to double function, and then we are going to retrieve the information using this get hash object here. So get, so you just copy the whole thing. This one you copy the whole thing. Okay, and then we're going to add codes to draw polygons using polar plotting and annotate the graph. Okay, so let's save and run icon. Okay, so to run this, okay, so when you have include this code inside the edit callback function, okay, you just click this button to run, and then you can enter the number of sides. Okay, for example 5, click enter. Okay, and then a polygon will be created using the polar coordinates here. Okay, so let's run this GUI again. Okay, so this is the polygon GUI. Type a value of sides. Okay, for example 3. Okay, and then you will get these 3-sided polygons plotted using the polar coordinates here. Okay, so you can close the figure. And then we're going to do another modification to our opening function of GUI. Okay, so the opening function is another sub-function that we need to modify in this file. So notice that when you execute this GUI, okay, the opening version of this polygon GUI displays as a rectangular axis. So in order to display an axis system consistent with the polar plot, we can modify the opening function of this polygon GUI by adding code to create a blank polar plot. Okay, so we can do that. First, go to the polygon GUI opening function. Okay, this one here. Next, we're going to add code to create a blank polar plot. Okay, so let's see down here. So this is another one. So right here, code to create blank polar plot, and then run and save. Okay, so now you have a different opening version than previous. So previously, when you run your GUI, it will open up a rectangular axis. So right now, by clicking a blank polar plot, okay, so you can enter the number of sides, and then it will be created along your polar coordinates here. Right, so you have now successfully created a GUI with one user interaction. Okay, one user interaction means there's only one user interaction. This is how user interacts with your GUI program. Okay, so in the next video, we're going to see how we can create a GUI with multiple user interactions. So let's continue to the next video.